Most of the time when we are thinking about composition functions, we're actually trying to decompose them and break them into two smaller components so that we can think about the general structure. We use them in this split up fashion a lot for derivatives in calculus. Looking at example A, we're trying to break this into two different functions where we have an outer function, which is going to be f, and then we have a different function, g, which is on the inside. So looking at the structure of example A, it looks like the overall structure, what I might call the outer function, is something raised to the third power, the something we'll call x. And the function that's on the inside is what's inside the parentheses. So that looks like x minus 5. Let's put together the composition function to see if this works. We want to get that h of x that we see over there. F of g of x would be, well, I take this whole thing and I plug it in for x here. So I would have x minus 5, the quantity cubed, and that is the h of x that we were trying to find. So these two are the functions that I was looking for. Looking at example B, it looks like the outer function, which we'll call f, is the square root. It's the general structure that I'm seeing is the square root of something. And then g of x is that function on the inside, which is a fraction. This is what's being plugged in to that function on the outside. For example C, it looks like I have the general structure, this one's a little bit tricky, is 4 plus x. And then what I'm plugging in is the cube root of x. So let's check this. I'm going to take this and exchange it for x here. So I get 4 plus the cube root of x. So that looks like the h of x that we were trying to find. And these are the two functions that will be composed to give us that h of x.